So, thank you for coming. Welcome. My name is Marek. I work at Red Hat and the OpenShift team. And today I would love to tell you something about OpenShift, and especially from the perspective of how to use it or how you can benefit as an engineer compared to using raw Kubernetes. And we will see the relationship there, why I'm speaking about Kubernetes and OpenShift in the same talk. Before I go into the talk, I will ask you a few questions, so please raise your hand if you are okay with the what I'm saying. You have tried OpenShift already. Awesome. You are very familiar with Docker. Okay. You are a bit familiar with Kubernetes. Okay, that's good. You are an engineer. That means the person who builds cool stuff. You are operations. That's the person who runs the cool stuff. Okay. You are a manager. That's the person who slows down the other two groups. Okay. So not many, I can make jokes. So because every presentation should start with an agenda, so my agenda is Kubernetes and OpenShift. So we have to give the formalities, everything that's supposed to be there. So first, something about Kubernetes, because, well, before I move to Kubernetes. So what I'm gonna show you is how to use both of those technologies, Kubernetes and OpenShift. And I am running a cluster, single node cluster of both of those on my laptop right here. This is the commands that I use to start the cluster. So it's the default configuration. I didn't add anything extra there. I didn't add ingress into Kubernetes because it's not there by default. So essentially, this is just what you get if you deploy the bare bones. And I pre-cached some of the Docker containers and things that I am going to use into my laptop as well. So during the demos, we should not be waiting too long. So there have been some preparation to that. I am using these two tools called Minikube and Minishift. So Minikube allows you to start Kubernetes in a VM on your laptop. I'm using Linux, so I'm using KVM driver. There is VirtualBox, Xhive on OS X, VMware, and other different drivers. So if you want to spin up a single node cluster that doesn't pollute your own machine, it creates a new VM, it downloads everything in there, and spins up the cluster in the VM, so that using Minikube and Minishift start, I spin it up, Minishift and Minikube delete will destroy the VM and clean everything after that. So it's a very convenient way how to do stuff, so I'm using that. And we will also use an application. So my application is written in Java EE because this is a Java conference, or at least it started as a Java conference. So it's written in Java EE. The source code is hosted on GitHub, and we will be using source code as well. That's why it's mentioned. To spin up the application, we will need one environment variable that points to some YAML file that describes what the application should do. And what the application does is it uses the YAML file to configure a content for a workshop. So when we are doing workshops, we are using this tool to deploy the content for the workshops for the people. So there are different modules, and you can go through these modules and follow the workshop. So the YAML file describes what modules are supposed to be there in the app. And there is a pre-built container on Docker Hub. So Docker IO SVG Workshopper. We are going to use that. That's pre-cached on my laptop in those clusters already. So this is the application that I'm going to use from the engineering perspective. And I wanted you to understand what the application does or why it was built. And this is the example that I'm going to be using during the demos. So something about Kubernetes. Well, I forgot one thing. I have books in here. If you will be active during the presentation, when I ask something, you answer, or you will have questions, you can get a book. I think it's like 19 or 18 of those. So these are for you. I will give them up. So be active and don't sleep. It's difficult after the lunch, I know. So Kubernetes started as a project from Google, and Google has been using containers for many years, even before containers were actually like hipster technology. Before we actually cared about containers, most of us, they have been using them. It's like 2004 or something like that. They started to use them, and they have two tools internally called Borg and Omega. They schedule the containers in Google infrastructure, and they try to open source also the container runtime. It was called "Let me contain that for you," limited epsilon. Well, difficult name, never got traction. I think it's because of the name, but doesn't have to be. I think even Google is now like phasing this out and is moving to Docker containers or something like that. And so, from their experience, how big is Google? That's a good question. Big. I usually think that Google is pretty much the biggest what we have right now in the infrastructure world, like what they do, what they run, what they have. Like I would say that they are bigger than Microsoft. Maybe even financially, but doesn't care. But technically, like infrastructure-wise, I think they're way bigger. The same compared to Amazon or something like that. So they have been using containers on that scale, and in Kubernetes, they are actually trying to open source the know-how, the lessons they learned the hard way, and put it into an open source project. So they are not open sourcing a technology that they have built. They are open sourcing the know-how, the ideas they learned during the time using containers in the project. And Kubernetes are designed specifically for running containers. So you have a container, you want to run it, and you want to run it in a highly available, resilient way. It should be it should scale somewhere. It should be deployed on a specific node, and there should be scheduler to decide which node. And all these things really are related to the runtime, only for running containers. Kubernetes doesn't care how you build the containers. They don't really care how you store the containers. You just say, deploy me this container, and it will be deployed. It can be built in any possible way. It can be stored in many different repositories or registries. But Kubernetes doesn't care about that, really. They don't provide this infrastructure. And they provide API, and on top of the API, there is a CLI tool, and there is a web console that allows you to communicate and use the tool for something you want to do. Maybe after every slide, I will ask if you have any questions, so we don't lose the context for the questions. So feel free to raise your hand if you have any questions. No. Okay. So Kubernetes, like by design, is not that difficult. It's quite simple, actually. And there are 4 different main objects or things in Kubernetes that you need to understand to be able to use it. So there are labels. That's a key value pair that you can attach to the other resources, like pods, replication controllers, or services. So every resource has several labels. And these labels are used for identifying these resources in the cluster. Pods. Kubernetes don't work with the concept of container. They work with the concept of pod. And pod is a set of containers that has the same lifecycle, is bound to the same network interface, is running on the same node. So it's containers that are always tied together. If you have your application like WordPress, and you have MySQL, should it be single pod or 2 pods? No, not single. These two have different life cycles. If your MySQL goes down, your WordPress can at least say, hey, I have a problem, come back later. And when the WordPress fails, MySQL is still running, and there is no need to tear it down just because the front end is not running. So these have different life cycles, so it should be 2 different pods. But if you have MySQL and some monitoring daemon that just fetches the information from the database and sends it to somewhere like Grafana or something that collects these metrics, This could be in single pod, because if you start the database, you want this daemon to start as well. If you stop database, you want to stop this daemon as well, because they have completely the same life cycle. When database starts, monitoring daemon starts. When you intentionally stop the database, you don't need the daemon running again, like for the time being. So this, like there is academic paper somewhere published by Google that describes different use cases for having multiple containers in a single pod. Though in my opinion, like I don't know, 80–90% of use cases when you use containers, you will have single container in a pod. Usually you don't have two containers there. So pod is a running container or set of containers somewhere. Replication controller says how many containers with a specific label is supposed to be there in the cluster. So as I said before, labels are attached to these different resources, and they identify those resources. So if my pod has a label app equals workshopper, for example, I have a replication controller that says there should be one replica of a pod that has a label app equals workshopper, and my container dies, my pod is going down. So there is 0 containers with that label. It will spin up new container to keep it on the level replicas 1. If I have too many of those, like if I want to scale down, I have, for example, replicas 2, and I change it to replicas 1, and it sees there is 5 containers or 2 containers that have this label or this set of labels. It will kill some of those containers to keep the level as it is described in the replicas value. So that's the concept of replication controller, who always maintains a specific number of containers with a specific set of labels in the cluster. And then there are services, because as I said, like the container can kill the containers, it can spin it down. So if you have 2 different pods that need to communicate with each other, they would need to know their own IP addresses. If a pod is destroyed, or if it died and is rescheduled somewhere else, it can change the IP address that it is assigned. So your application that's trying to consume something from that application that died would need to reconfigure itself to go to the new IP address instead of the old one. So services provide a stable IP address that works as a load balancer to a specific set of containers behind them. So what happens again is you say, I am a load balancer or a proxy to different services that have this set of labels. And anything that is there in the cluster and has this set of labels will be considered a backend for this proxy or load balancer. Well, I usually use the word proxy when there is only one pod, and load balancer when there are multiple pods behind that service. But I think they could be, in this case, like changed just fine. So this is essentially how Kubernetes works. What you do is you create a replication controller that describes a pod. You change the number of replicas to 1. It will create a pod. You have something there. You have a service that manages the traffic to that container, and that's it. So that's essentially how Kubernetes works. There are new concepts there that are extending these basic ideas. So as a replication controller is a parent to pod, there is deployment that is parent to replication controller. If you need to, for example, if you are doing a rolling deployment of something and you want to redeploy the application, what you do is you have application with replicas, for example, 5. There is 5 pods, and a replication controller that says that there should be 5 pods of this type. So if you want to do a rolling deployment, and by rolling I mean I spin up a new container. If it works, I will tier 1 down, right? So I will create a new replication controller with replicas 0, and I will scale this to 1. If the container works, I will scale this to 4. I will scale this to 2. If it works, scale this to 3, and I will like in a linear way, or whatever you configure. It's up to you. You can just do a rolling deployment of the application. So, and this is maintained in the deployments who are parent to application controllers. That's why there is the parent-child relationship, because something manages something below. Replication controllers manages pods, and deployment manages replication controllers. And with services, in Kubernetes there is ingress that allow. Was there a question? No? Yes. I heard something. So there is ingress, and ingress allows you to access something in the cluster from outside. That's usually HTTP based, and based on the host header in the HTTP protocol, it decides what should be the container that is the backend for this particular request that is coming from the client. So it was a lot of words. Let's do something. So I will try to show you how to actually use Kubernetes in a very simple way, and we will deploy the application that I mentioned at the beginning, and we need to deploy it using the container that has been pre-built, because Kubernetes itself doesn't allow building containers. So because I don't want to build containers myself, it's pain, and I don't want to do Docker pushes and this kind of stuff. So what I have in place is, when you do Docker git push to Docker Hub, trigger a Travis CI build. This builds my application and then creates a container that is then pushed to Docker Hub. So I have this workflow there, but it's outside of the cluster itself. The same goes for the registry. As a registry, I am using Docker Hub. The registry is not part of the Kubernetes cluster itself. Yeah. So what you can do, well, I think in Kubernetes it's optional. In OpenShift, then it's part of the default deployment. But there is a DNS server or DNS service running inside a cluster, or can be, and that one is going to resolve a name to some IP address. So you can have 2 types of services, and one is called headless, one is called normal, or whatever. And they always have a name. So from your front end to back, if you're communicating from front end to the back end, you will name your service that is working as a proxy or load balancer for the backend containers. You will name it backend, for example. So when you try to go to it's a synthetic DNS name, like service name dot svc dot cluster dot something, or something like that. And you can use this domain name that is well known to actually identify that service, if it's a normal service, and it will choose one of those containers and will proxy the request there. If you don't want to use the service as a load balancer, but you would like to use it as a discovery protocol or a discovery feature, you can use the headless service. And when you do a DNS query to a headless service, it doesn't choose one IP address, but reports all the IP addresses of all the pods that are behind that particular service. So you can actually discover all the services there just using the DNS query to the service if it's headless. If it's not headless, then it reports only one in a round-robin fashion. Does that answer your question? Awesome. So do you want the book? Do you want to come now or later? Okay. Some other questions? I'm really not kidding. The books are for you if you ask the questions. Yes? And what do you mean by automated? Yes, there is a auto-scaling feature, or I think it's called autoscaler, something like that, that can monitor some of the metrics of the pods and decide based on the metrics if it should scale up and scale down. And it should be there as a component that you can deploy with Kubernetes. So it could be automated. Book for you. I know it was just for the book. Yeah, I don't think so. I think in the current versions, they don't do automatic rebalancing of the cluster when there are new resources. Just the new containers would be getting to do that particular node because there is most resources, so everything that's new will go there. But it will. I don't think that it will automatically just take something from the other nodes and reschedule just because there is a new node. Yes. So the question was if there is a new node connected to a cluster, if Kubernetes is going to rebalance the whole cluster and put some of the containers that already exist on that new node. That was the question. 3 books down. Okay. So we will need a command line. We will need a browser. So this is the console of Kubernetes when it's deployed and it's completely empty. And I prepared the commands in a text file here for me. So this command is going to deploy the application for us, because if I would type it myself, I would definitely make some mistake there, some typo. So let me do it this way. So this is the command that we need to run. So can you read it? Is it readable? Okay, it's not readable for me from down here because it's so huge. So kubectl is the Kubernetes CLI tool. Run something. Workshopper is a name. It will use a Docker image from Docker Hub. It will expose port 8080 from the container to my machine, and there is the environment variable that I need that was mentioned in the first slide. Because in the default there is no ingress or no HTTP system there for translating, so I need to expose the port. There is no nice entry point that would allow me to get to my service. So if I do it, it's very fast, and because I already cached the image, it shouldn't take too long to deploy it. So you see that there is a new deployment, there is a new replica set. Replica sets are replacing replication contours. They have slightly different behavior towards the labels, and there is a pod. So I created a new deployment that created a new replica set, and replica set created a new pod. So let's see if it's already there. It's there. It's running. So it's green. We have a pod running. So our application is running at this time. I will need this IP address that is exposed from my. And I used 9090. Some application should be there. And it's running. So I can really click it. It works. It should work. Yeah. So that's my application. It has been deployed on Kubernetes. So it's quite easy, but there is nothing fancy. I still had to build my container myself somewhere. I couldn't build it in the cluster. And it runs it for me, but that's pretty much it. That's how it helps me just to run the container. It will not help me to build a container, maintain the containers, rebuild them if there is a problem or something like that. And that's what OpenShift is putting on top of Kubernetes, and that's one of the features that we are adding. So this was just to get you started with Kubernetes, so you see how it works if you want to run a container. But now I will move over to to the slides again. Oh, because I had a problem with my Wi-Fi. It doesn't work at all. So I'm connected through my mobile phone, and everything's done through the 4G. So I put the screenshots of the different steps if there was no signal or something. So I have some backup just to show you something. So when you run Minikube, start with the KVM, it will do these steps. So that actually what happens when you try to install Kubernetes using the Minikube. Then I run the command. That's my screenshot of the screen, and that's my application, right? So that's pretty much what I showed you as well. So now moving over to OpenShift. OpenShift has some history. So OpenShift is a project and produced by Red Hat. But today I'm speaking mostly about the project, the open source part. Yes? Right now, my Kubernetes, it runs in a VM. So there is a KVM virtualizer. That's a crazy word. Running on my machine, and in that virtual manager, I have two virtual machines, Minikube and Minishift. So in Minikube VM, there is a Kubernetes deployed there, and I was communicating with it. It's not running on my machine directly, it's in the VM on my machine. Inside that VM, yes. Yeah. So it has its own Docker in there, and it's using the internal infrastructure inside, so it doesn't pollute my system outside of the VM. I could do the same thing, you can do something like kubectl start or deploy or something like that, or kubeadm start or deploy, and it will start it on your own machine directly. So you don't have to go through the VM process, and it's quite easy as well. But I like the containment, yes. The containment in the VM, so I can just do a Minikube delete, and it destroys all the things there, and I can start from scratch. Yes, so kubectl is just the front end to the kube API running in the VM that's HTTP based, so just communicate with each other. I think it's HTTP based. Yes, yes. Yeah, if you for example go to, I don't know, Google container engine, whatever they call it, you can use kubectl against that or some other. There are different profiles or contexts, so you can switch between different instances of Kubernetes and just communicate with one specific. Generally, just HTTP endpoint that you just communicate with, so it can be wherever you want. The nice thing with Minikube is it will actually create this context for me on my machine, so I don't have to log in or set something manually. It's created there, it's called Minikube. Very simple to understand. It's up to you, you can specify that. I think by default they use 2 gigabytes. Where is it now? This one. So by default 2 gigabytes of memory, and it is using 2 CPUs of my 4 CPUs on the laptop. That's the default configuration. But you can, using the command line switches, you can choose your own configuration of the VM. It's up to you. Oh, the application inside the container? Ooh. Well, there could be something here reported, but I'm not sure if it's really there. No. I don't know, really. It's a Wildfly application server that is running a quite simple Java EE application that is using pretty much only the servlet and CDI specifications. So most of these subsystems are probably disabled. I would shoot like 200-300 megabytes, but that's just my guess. Okay, we have all still the same people. I don't want to give them the same book again and again and again. Different people ask questions as well, if you have some. Yes, I will try. Just wave on me when I start answering right away. I will try to remember. So going over here. So we started with OpenShift 5 years ago. Who knew about Docker 2 years ago? Who knew about Docker 3 years ago? Yeah. So we started way before Docker was there. At that time, actually, the company was called .cloud. They were trying to build a platform as a service. And they built this technology that allowed the layered approach to containers and distribution of the application. So they eventually decided, hey, our business in the platform as a service land is not going that well. Let's just do the technology we use with the layers and containers, and let's build business around it, and it's called Docker. So actually, Docker was created as a side project, or like as a component of a bigger thing that was then like somehow transformed the company into a Docker company. At the time there was no Docker really, so we created our own container technology that was called Gears. It was pretty much some LXC with SE Linux that created a secured environment and allowed the application to run there. And we had our own scheduler. The whole thing was written in Ruby. I like Ruby, so I was happy, though some of the customers who were deploying the platform were complaining that it's pretty complex, and Ruby, that it's not really stable, and I don't know. So there has been a lot of moving parts there, and there were some problems. So eventually when Docker came and our customers started to asking for using Docker, so we want to use Docker with your platform. Can we do it? We didn't have the answer at that time. So we were deciding, should we ditch the Gears and use Docker? Should we support both, or what will be the future? And at the same time, Google was starting to open source Kubernetes. And we did the decision that, hey, okay, let's cut it here, and let's adopt Docker for the container technology, and let's adopt Kubernetes for the scheduler. So we actually ditched the previous code and used these two. Right now, in my opinion, like Kubernetes is becoming definitely the standard or like the most common way to deploy containers. Though there are of course some other tools. So it was a nice decision. And Docker, when somebody says container, most people think of Docker actually, even though there is Rocket and some other implementations and some older implementations, right? What was the first container technology? And this is like my own opinion. Some people disagree with me that it is a container technology, but I still think it is a container technology. Root, change root on Linux. Like, it didn't allow you to isolate really the resources, but you were able to switch into different contexts of the machine and do something in there. So I think like that was one of the first. Then we had Solaris zones, containers, then we had FreeBSD shells, then we have Linux LXC, and we evolved into Docker eventually. We have Docker, Rocket, and there are some other implementations as well. So that's just something to the history. And something about OpenShift itself. So I like to call OpenShift a distribution of Kubernetes. If you want to use OpenShift as a Kubernetes cluster, you can. You can take kubectl and just run the commands against the OpenShift cluster, and it will just works. All the things from Kubernetes are exposed back to the user. And there is the word enterprise. That's because Red Hat's business is in doing products and projects for the big guys, for enterprises, right? So what we do is, if our customer asks like, hey, I want a Kubernetes running on Enterprise Linux. Can you do it for me? Yeah, we have OpenShift. You can use OpenShift as a Kubernetes cluster as well. So that's why I call it enterprise distribution of Kubernetes. And it also adds some other features like multi-tenancy. Like in Kubernetes cluster, everybody's pretty much equal, and there is no role-based access. We have like different projects that isolates all the resources. and different users can do only different things and this kind of stuff. It's like things that allow you to use the platform as a multi-tenant system. Multiple users can use it without interfering with each other. We also do this on the network level, so every project can have a virtual network just by itself. So different projects cannot see the communication from different other projects. Plus, what I want to speak today about most is the developer experience. So we take OpenShift and we take Kubernetes and build around the developer experience so that you can use the platform as well for building containers, for managing containers, and somehow cover the whole life cycle of a container from its inception to its runtime or production in the same tool. Because Kubernetes itself is only the last part of that process, but we try to cover the whole life cycle of the container. Okay, that's enough for the introductions. And let's do something again with the demo. Questions? And I will remember to, no questions. I will not remember to repeat them. So what I have here, there is a OpenShift origin running over here. Origin is the open source project. So if you want to get the open source project or access the source code or use the use it, you can go to github.com/OpenShift/origin, and right there you can download OpenShift, which is a single binary in the simplest case, and you can spin it up if you want. You can use it for whatever you want. It's Apache 2 licensed, so you can contribute back. You can build something from the source code. Everything's right there on GitHub. So my project is here. So I have one project only, and I can do things in there. So the project, when I'm inside the project, I am pretty much in the same scope as I was in the general view of the Kubernetes cluster before. So this time I need to select a project to actually work in some specific namespace. So what shall we do? We shall deploy the container again. Exactly the same thing as we did. Just pull something from Docker Hub, spin it up, and get it running on this cluster instead of on Kubernetes. So I could very much use the same command as I did before, but we also have our command line too. Oh, one more thing is that before I can use it on the command line, I need to log in into my username with my password and choose a project. So I work somewhere. You didn't see it in Kubernetes because it's not needed there. Everybody has access pretty much everywhere. So I am logged in. Where is my this Minishift console would just launch the browser with the console with the IP address of the VM, so I don't have to remember it myself. What the URL over here, so what I do, OC login, I would need to have the address of the cluster, so I'm using the console-URL instead of opening the browser. I am printing it out to std out, and then logging in using a username and a password. It's quite easy. So this is the command that I need to run to deploy the application. Oh. So OC, there's instead of kubectl, new app, my container, and the environment variable. This time I'm not exposing any ports because I don't need it. I already have HAProxy running on the platform that is doing the HTTP translation for me. So it's there as part of the platform by itself. When I switch over to the browser, there is my application. There is one pod being deployed. Now it's blue, so it's running. We are exposing port 8080, but there is no, like right now, the application is isolated inside the platform. It's not accessible from outside. What I need to do is create a route. So I create a new route. I will just use the defaults. I'm using the port 8080. Oh, I closed it. So nothing changed except that I have my DNS name right now already. So I can open it and it was translated. So what's happening here right now is that I have already a domain name. So I'm using a domain name that is, and I am hitting HA proxy, and HA proxy decides what service is supposed to be backend for that, and then I hit the container itself. So I don't need to expose a port or something. I can just use the translation layer. This is useful for HTTP, right? Because HTTP protocol is simple to translate into something using the host header. The other protocols are way, way more challenging. So that's it. I have application running. So this is the same as we did in Kubernetes. Again, very simple. So I will clean it up. OC delete all -l app equals workshopper. So I'm deleting everything that has a label app equals workshopper. When you create something, it will automatically label all the resources with some specific label. So this one deletes everything that's there related to my application. So nothing's in here. So this time I'm gonna run the other command I prepared, and that's this one. Control C. Where's my console? Like that. So OC new app, the same thing, but this time I have wildfly tilde, a URL that points on my GitHub repository, dash name, which it's not required there because it would be guessed from the base name of the URL, and then the environment variable again. What's going to happen this time is I'm going to create a new build, and if it's wildfly, so my build is running here. It was not here before. I hope I cached the correct wildfly image. Yeah, I guess I did. So I'm cloning my repo into the platform, and it will use the wildfly container who has been configured also for building stuff. So it will detect that there is a POM XML file. It will, come on, go. My Wi-Fi is still up, should work. So it will use the image, and the image knows how to build application. But there is POM XML file, it will run Maven build, and then from the target directory, it will use the will take the war files, ER files, and this kind of stuff, and will put it into the deployments directory of Wildfly, and it will take this image, this container, it will commit it as an image, and will push it into internal Docker repository that's running inside OpenShift. So when this happens, OpenShift will detect that there is a new image for this application. It will pull it and spin it up. So it will start Wildfly, and it will automatically deploy or the WAR file or ER files that have been there from the build. So I don't have to pre-build anything myself before. I can use the platform to build the container for me. Oh yeah, we are downloading the whole internet now through Maven. So the platform is pulling all these things, and it will run the build. Once the build finishes, it will create a new container, and yeah, copying the artifact, pushing a new container, and you see there is an internal IP address. So it's inside the platform. So I'm not pushing into Docker Hub or anything like that. Yes. Fabricate replicates some of the features. Sorry, this looks very similar to Fabricate, was the question. Yeah, they have quite they have similar features, some of those features. Some of those features are actually just things that they use in OpenShift and just expose it in a different way. They are trying to build a different user experience for engineers than we have in OpenShift itself. And this is mostly the matter of personal opinion, what you like, what you think is better. Some people would prefer this user experience. Some people would say Fabricate is great and I want to use this user experience. So one book for you as well. Still pushing, as everything's happening in my single VM, Docker push is quite demanding on CPU because we are calculating the hashes and stuff and validating them, so it takes some time before everything's pushed, especially for the big layers. Yes? In OpenShift or in general? Okay. Oh, definitely. We have like big customers in the area of, I don't know, airports, banks, government, military. Uh, yes, it's deployed in wide scale. It's deployed across industries, and we put a lot of security or constraining stuff on top of the containers. So by default, everything's isolated in a C Linux. We, like by default, we never run container as a root container. We always run it as a specific user, which in essence breaks a lot of containers from Docker Hub. But also, it puts a security layer on top of the container because you are not root, so you cannot do a lot of stuff, right? So sometimes people see OpenShift and they say, hey, my container is not working. Yes, because your container was built in a way that it probably shouldn't be, because there are still no user namespaces in the kernel in the way that it should be. So once it's there, the technology to actually isolate, like in container, be seen as a root, but be a regular user on the machine itself, then it could be possible to use it this way. Though at this time, even if you use the user namespaces that are there right now, you can be a root in the container to be seen as a root in the container, but you will be always a single user for all containers on the machine. So if you break out, you will have access to many different containers because you're still the same user. So there is still security aspect that needs to be fixed to actually use containers in a root manner. So maybe some of those things may come from people using it in a way that it not, well, it's difficult to say not meant to be, because everybody has a different opinion about how to do stuff, right? But I don't know, like we have customers who actually run it in production, they use it, and it works for them. So we have the experience that it works. Yes. No, that's just a general Docker repo. If I go to caps lock github.com/osg workshopper. Yeah. So I do have Travis YAML and Dockerfile because that's used for building the container and pushing it to the Docker as a Docker image to Docker Hub. But it's not required for the application itself. The only thing is that the WAD image knows that if there is a POM XML file, it should run a Maven build and take the artifacts from there and configure itself to use these artifacts. That's pretty much it. So the application, it's independent from the platform. The builder image needs to understand how to build that particular technology. So Wildfly understands how to build Maven, maybe Ant or some other technologies. There is a builder image for Ruby, Docker, Perl, PHP, some other technologies as well. If you have something that you need to do specific to your own company, to your own deployment, you can just do from Wildfly builder image, change something in the builder image, and use that new container as the builder image for your use cases. So it has more features than ours have, because there is something specific to your company that you need to have there. Make sense? Cool. Yes. Well, let me show something, because I think I'm running out of time slowly. I will do one more command that will do something, and then we can, while it's happening, we can discuss things. So my build finished. My application is running. I can access it again, and I should see my workshop. So it works. It's not exactly the same, but it's very much the same as pulling the Docker image, but I am building it in the platform instead of building it outside of the platform. This is good, but not always you want to build or git push to GitHub repo and then trigger the build from the GitHub repo. You want to build from your source code directly. So the last thing that I want to show you is that I will use the same configuration the same thing. The only thing is that I will trigger the build with start build for workshopper, and from directory this. Oh, I'm in the wrong directory. So let me change cd like that. So this is the source code of my application, and I want to use from this directory this application. Don't use the GitHub repo we specified before, but use the source code in my application right now. So when I go back to my console and I check the log, there is the cloning here, right? So I'm cloning the GitHub repo. That was the one that we did before. Now I will run this, and second build was triggered, so I can see the log over here. And this time there is no git clone. I am using some archive from stdi in. So I am actually uploading. I compressed my source code on my machine, uploaded that archive, and OpenShift took the archive as input instead of Docker clone, and is using the source code directly. And it's not using the GitHub repo or the source code there. It's just what I had on my machine at that specific time. And then it happens the same. So your questions. No, so what I did, what the platform did is it took the Wildfly image, it cloned the repository in the image, and then there are two shell scripts called assemble and run in a well-known path inside the container. So the platform, if you want to build your own container, you need to put the scripts in the container, and then you need to add some labels or in the metadata of the container to actually specify what script should be used as assemble and run. And assemble is used for the build process, and when the container is committed, the run script is set as the entry point. So when the container is started, it will use the run script to boot the container itself. Does it answer the question? Awesome. No, the person behind you was first. You want to redeploy the container one by one in a rolling manner. Yeah. Sorry. So I think I'm not sure what's now the default in Kubernetes, but in OpenShift the default is to use rolling strategy. So essentially by default, if you try to deploy new version of your application, it will be done in the rolling manner. So it will spin up new container. If it works, it will tear one down and go this way. So that's the default that we use. Then you can have like kill everything, deploy everything, kill everything, or something that could be custom, like some way of scripting. But the default is rolling right now. You are. No, we are pushing it into the internal registry that is running as part of the platform. So inside the VM that OpenShift is in, there is also a registry running. So it's completely internal. You can access it and you can like pull or push from there if you want, but you don't have to. The registry? Or? No, it can be used for production as well. Pretty much in every deployment of OpenShift, you will have a registry that's used for the images that are produced by the platform. It's also used for caching these images and this kind of stuff. You were next. My application over here. Yeah. Uh-huh. You can have, so we are using, so the translation that is translating the DNS into some internal container is HA proxy running in a container on OpenShift. You can scale the router as well. So you can have multiple nodes that will work as the gateway into the platform. So you can scale the part that translates, though you still need something in front of that that will work as load balancer or something. So the platform can be highly available, but if you are, for example, in AWS, they have this load balancer that can be there as a publicly facing endpoint and then use some of the backends. So then you can scale the HA proxies and then you can scale the containers. So this can be highly available. I don't know, just decide yourself. Uh-huh. Mm-hmm. Okay. So essentially the question is how to do multiple stages of the application and deployment in different stages of the lifecycle, QA, prod, dev, etc. So this could be a talk just by itself because there are different patterns to do it. If you have single OpenShift cluster, the container has something called node selector. So that says what nodes it should be deployed to. Nodes can have labels. So this is again based on labels. So you can say this container should be on node that has zone dev, zone prod, or something like that. And by changing this selector, you will move the container to different zones. So that means that you can even you can specify different hardware that is going to be used for production, for development, for QA. So this is the lowest level, right? If you move one level up, or like what you mentioned, how to like structure the access to the database that is used somewhere differently. So the simplest use case would be, or the simplest solution, if you are in if you are in QA, dev, and this kind of environments, the database will be running on the platform probably inside the project. So you will just have a service called database. So you will access the database domain name, and it will point to a container running inside the platform. But services don't have to point only on the on things inside the platform. They can also point to things outside of the platform. So for production, for example, you can create a service that will be again called database, but it will not point to a container. It will point to a database cluster running on different nodes. So you will connect to the local service, and that will transfer it somewhere out. So from the perspective of your database, you are always connecting, for example, to database name, the host name database, and you are reading the username and password from environment variables or something. And then as the application moves through different stages, it will, without changing the code, connect to different databases and use different credentials based on the information either in the environment, or you can have config maps that will create a file on the disk that you can read from. There are different ways how to distribute the configuration information inside the application itself. Does it answer the question? Yes. Now there was somebody at the back. Yes. Uh-huh. Yes. Not really. It's not meant for that. So there are two checks, two probes. One is called readiness probe, and one is called liveness probe. So readiness probe checks if the container has already started. Example is Wildfly. When the process is started, the Wildfly process, it doesn't mean that the application is deployed and it's running. It's not available yet. So you get 500 or 404 because the application is not yet there. So for example, here I could do readiness probe, HTTP GET to my application, and unless it responds with, I think, 300 something or 200 something, it will not add this pod into the load balancer, into the service. So it's not yet available. Once this probe actually returns a correct answer, then it will be added as a backend to the service. So it will be usable. Liveness probe works, checks in the same manner, but checks if the application is available. If liveness probe fails, the container is considered dead. It will be unscheduled and will be rescheduled somewhere else. So there are two probes for this. It's not really meant for monitoring itself, like monitoring in Grafana or something like that. It is meant for checking the state of the container inside the platform. It can be HTTP request, it can be TCP connection to some port, or it can be a script run inside the container. So there is script in a container, it will be run. If it exits with an error, it will be considered not okay. If it exits with 0, it's okay. So that's what the health checks are for. Not sure what you mean. Let me see. So we were over here, right? Yeah. So it just shows what was happening inside the platform. That's a like overview of different things. What you probably would like to see more is if you go to application pods, you open one of the pods. You have logs here, so you see what printed to std out std error of the container. You can use terminal, so you can do something like this, run directly inside the container. Or I can have two more things here, like can be metrics that will show memory, CPU, and some I/O charts and stuff around about the container, which is not deployed here because it uses Cassandra and it's too big for my VMs running on my node, my machine. Or it can be you can have a logging, which is using FluentD to stream all the logs from nodes, from containers into Elasticsearch or Splunk or something like that, and then you can aggregate the information from there. So there are different ways how to do monitoring, but those things that you spoke about were more metric or like the state of the container checks. There's so many questions. I think you were next. I have this question quite a lot. I would say that it's much more flexible. It has much more features. Though with Amazon, they are moving rapidly forward as well, so they are adding features all the time. I would say if you are considering that or that, try both and decide yourself based on your own experience if it fits to your use case. For some use cases, you may prefer to use their service like natively. Some customers are running OpenShift on AWS themselves instead of that, the service that Amazon provides. So there are different workflows, different features, and I think like it's better to just go do some hands-on test and see if it fits your needs. One more question at the back somewhere. No? Are we overflowing? A lot? Oh, that's cool. So, if there are no more questions, So, yeah, there is a concept of persistent volumes. Persistent volumes define that there is somewhere a persistent system. It can be Gluster, Ceph, EBS on AWS, some Google Disk or something like that. So different things can be hidden behind persistent volume. And then you, as a user, you create a persistent volume claim that says, I need a persistent volume with these parameters. It will choose one of those based on some metrics and stuff that you choose. It will try to match them. And then you have persistent volume claim, and that claim can be attached to a pod. And it says, mount this technology inside this particular container at a specific path. So then you can use this directory as a persistent directory, and the rest of the container still is ephemeral. Okay. Okay. Yeah. So in containers, pretty much the best thing you can do is to stream everything to std out from the application. And the container technology usually streams everything from there. So whatever you print as an application to std out in the container, we will take, and through fluentd, we will send to some technology that aggregates this. By default, it's Elasticsearch running on OpenShift, but it can be Splunk or some other solution that you are already using in your company. Okay, I think I am really overflowing. So thank you for coming. You were a great audience. These books are over here, so please come and take. I think there is not enough questions, so if there are some left, you can take them as well. I'm not taking them. I don't want to travel with them home. And these are my screenshots, and thank you.